Have you ever stopped to think about how your favorite app, that website you just scrolled through, and the AI you're chatting with all manage to understand each other? Well, behind almost everything we do online, there's a single universal language that structures our entire digital world. And today, we're going to decode it. So, what is this secret language? I mean, you've got countless different systems, all built by different people using totally different technologies. How in the world do they all communicate so seamlessly? What's the internet's universal translator? The answer is JSON. It stands for JavaScript Object Notation, but you can just think of it as a super lightweight way to package up data. It's like the Rosetta Stone for computers. It takes complex information and organizes it into a simple text-based structure that basically any system, anywhere, can instantly understand. All right, so here's our game plan. First, we'll break down why JSON is the universal blueprint for data. Then we'll get into its super strict, non-negotiable rules. After that, we'll see it out in the wild, explore the new challenge of teaching AI to speak its language. And finally, we'll talk about why getting this right is so critical for AI safety. Okay, let's start at the very beginning. At its heart, JSON is just a blueprint. It's a way of organizing information that is incredibly straightforward for both people and, more importantly, computers to read and understand. And this slide really gets to the heart of why JSON took over the world. Its goals were simple. It had to be minimal, no extra junk. It had to be portable so it could work on any machine, and being text-based, a human can actually open a file and read it, which was a huge leg up on older formats. But that last point, being a subset of JavaScript, that was the real game changer. It meant web developers could use it right out of the box, and that's what cemented it as the official language of the web. And here's the beautiful part. It's so simple. The entire JSON universe is built from just these 6 things. You have objects to hold pairs of keys and values, arrays to hold ordered lists, and then the absolute basics: strings for text, numbers, simple true or false booleans, and null, which just means nothing. That is it. Any piece of data you can imagine is just some combination of these 6 types. Okay, so the building blocks are simple, right? But here's the catch. The rules for putting them together are incredibly strict. They are absolutely non-negotiable. One tiny mistake, one character out of place, and the whole thing comes crashing down. And, it's often the smallest character that causes the biggest headaches. The number one culprit? The comma. It's just there to separate different items. You forget one, or you add an extra one where it doesn't belong, and any program trying to read that data will just give up. Here's a perfect example of what I mean. See on the left, there's that extra little comma after traveling. To you and me, it looks fine, our brains just ignore it. But to a machine, that is a fatal syntax error. The proper way on the right removes it. It's a tiny detail, but it's literally the difference between a working application and a frustrating error message. Rule number 2 is another classic. It's all about the quotes. In the world of JSON, everything, all the keys, all the text values, must use double quotes. Single quotes, which are totally fine in a lot of other programming languages, are strictly forbidden here. No exceptions. And that brings us to another common pitfall, just wrapping everything in quotes and calling it a day. On the left, the age 23 and the student status false are being treated as text, but that's not right. The proper approach uses the correct data types. 23 is a number, and false is a Boolean. And this isn't just about style, it's so the system receiving the data knows how to actually use it correctly. So we've learned the rules. Now let's go out and see where JSON actually lives in the real world. And the short answer is pretty much everywhere. It's the invisible backbone of the modern web. What you're looking at here is a peek behind the curtain. This is a tool that developers use to talk to APIs. Think about it. When your weather app needs to know the temperature, it sends a request to a server. And what does it get back? It gets back this, a perfectly structured JSON object with all the data it needs. Every single time you refresh your social media feed, a transfer just like this is happening in the background. So if JSON is the standard way machines talk to each other, it makes total sense that AI is the next frontier. We've got these unbelievably powerful large language models, but teaching them to follow the strict, unforgiving rules of JSON, that's turned out to be a massive challenge. It's kind of a weird paradox, isn't it? You can ask an LLM to write a beautiful, moving poem, and it will. But then you ask it for a simple piece of structured data, and it might just throw in an extra comma and break your entire workflow. For AI to be truly useful in automated systems, it has to be precise. So, how do we get these creative AIs to color inside the lines? The solution is something called guided decoding. Basically, instead of letting the AI just generate text freely, these techniques act like guardrails. Think of it like a spell checker on steroids. Some methods just nudge the AI's word choices to fit the right structure, while others, like LM Format Enforcer, are super strict. They check every single character the AI produces to make sure it's perfect JSON. Now I know, a table full of numbers can make your eyes glaze over. But what this shows is the raw data from research. They tested these different guardrail methods to see how often they still messed up, what they call a false positive. It's basically the percentage of time the AI still failed to create valid JSON. But looking at it like this is tough. So let's visualize it instead. This bar chart makes it much easier to see what's going on. That LM Format Enforcer, the really strict one, generally has the lowest error rate. And what's really interesting is that for the llama model, the error rate plummets after a second turn in the conversation. It shows that giving the AI more context, along with the right guardrails, really does make it more reliable. And this whole discussion about forcing AI to follow strict rules brings us to our final and maybe most important point. Getting predictable, structured output from an AI isn't just about making sure your app doesn't crash. It's a fundamental piece of AI security. This is basically what a modern, defended AI system looks like. It's not just one wall, it's a series of security checkpoints. You have a system prompt that sets the ground rules. You have code-based filters checking for bad stuff. And you might even have another AI acting as a final sanity check. This is how you try to protect sensitive data. But of course, attackers are always looking for clever loopholes. This is a perfect example of a prompt injection attack. A simple security filter might be programmed to block any request that contains the word secret. So what does the attacker do? They hide it. They ask the AI to make a JSON object, but they break the secret key up into individual characters in an array. To the AI, this looks like a harmless request, and it happily complies, sneaking right past the filter. So here's the main takeaway. Forcing an AI to produce perfect, structured JSON isn't just about quality control. It's about making its behavior predictable. And predictable behavior is safe behavior. When we can guarantee the format of the output, we can build much smarter, more robust security filters that are a whole lot harder to trick. And that leaves us with one final big question to think about. JSON gave us a universal language for data. Now, as AI becomes fluent in that language, we're in a mad dash to write the next set of rules. Rules for behavior, for safety, and for security. The question is, who's going to be the one to write them?